Black holes are among the most terrifying and fascinating objects in the universe. They are places where gravity becomes so powerful that the normal rules of space and time begin to collapse. They are not just distant cosmic oddities, they are laboratories where reality itself is pushed to its limits. For decades, black holes have captured the imagination of scientists and storytellers alike because they challenge everything we think we understand about physics, matter, and existence. But what would truly happen if a human being fell into one? The real answer is far stranger, darker, and more mind-bending than any science fiction story. Black holes are not empty space. Despite their ominous name, black holes are not holes in space, and they are not empty voids. They are physical objects with mass, formed when a massive star collapses under its own gravity. When a star much larger than our Sun runs out of nuclear fuel, it explodes in a supernova. What remains is the star's core. If that core is heavy enough, gravity overwhelms every known force in nature and crushes the matter into an unimaginably small volume. This collapse creates a black hole, an object so dense that it dramatically warps space and time around it. To understand how extreme this density is, consider our Sun. Its gravity is already 28 times stronger than Earth's. If you could stand on the Sun, you would instantly weigh 28 times more. Now imagine squeezing several suns into a sphere only a few dozen kilometers wide. That is the scale of compression inside a black hole. This is why black holes do not behave like normal stars or planets. Their gravity is so intense that it reshapes the geometry of the universe itself. Why black holes are invisible. Black holes cannot be seen directly because not even light can escape their gravitational grip. Once light crosses a certain boundary, it is trapped forever. This is why black holes appear perfectly black against space. However, astronomers can detect them indirectly. Gas and dust falling toward a black hole heat up to millions of degrees, releasing powerful X-rays and gamma rays. Entire stars can be torn apart, creating brilliant cosmic flares. By observing how nearby stars orbit an invisible object, scientists can map the presence of a black hole even when it cannot be seen. In this way, black holes reveal themselves not through light, but through their influence. They announce their existence by bending space, warping orbits, and devouring matter. The event horizon. Surrounding every black hole is a boundary known as the event horizon. This is the point where gravity becomes so strong that escape is impossible. Cross this line, and no signal, no particle, and no message can ever return to the outside universe. It is the ultimate one-way door of physics. From far away, a black hole does not look like a giant vacuum cleaner. You could safely orbit it, just as planets orbit stars, provided you remain at a distance. But once you drift too close, gravity begins to dominate your fate. As you approach the event horizon, your speed increases rapidly, pulled inward by space-time itself. The stretching of the human body. As you fall toward a black hole, gravity does not pull equally on your entire body. Your feet, being closer to the black hole, feel a stronger pull than your head. This difference becomes extreme near the event horizon. Your body begins to stretch vertically. Your spine lengthens, your organs shift, and your blood is pulled downward. Physicists call this process spaghettification because the body is stretched into a long, thin shape. If you fall into a small, stellar mass black hole, this stretching becomes fatal long before you reach the event horizon. The gravitational difference across your body becomes so strong that you would be torn apart at the atomic level. You would never even cross the boundary alive. Why supermassive black holes are more deceptive. At the centers of galaxies lie supermassive black holes, millions or billions of times heavier than the Sun. The black hole at the center of our own Milky Way is about 4 million solar masses. In these giants, the event horizon is enormous, and the gravitational difference between your feet and your head near the horizon is smaller. This means you could cross the event horizon without being immediately ripped apart. This creates a terrifying situation. There would be no dramatic moment, no explosion, no sudden warning. You would simply drift past the boundary without noticing anything unusual. By the time you realize what had happened, it would already be too late. Time slows and reality distorts. To an outside observer, your fall would appear strange. As you approach the event horizon, your movement would seem to slow down. Your image would fade and redden due to extreme gravitational effects on light. You would appear frozen in time, hovering at the edge forever. From your own perspective, however, time would feel normal. You would cross the event horizon in seconds. This difference happens because black holes distort time itself. Near the event horizon, time slows dramatically relative to the rest of the universe. Space and time become twisted so severely that they begin to exchange roles. Inside the black hole, moving forward in time becomes as unavoidable as falling forward in space. There is no direction that leads back out. The descent toward the singularity. Deep inside the black hole lies the singularity, a point where matter is crushed to infinite density. As you fall deeper, gravity becomes stronger and stronger. Even inside a supermassive black hole, spaghettification eventually returns. Your body is stretched thinner and thinner. Atoms are pulled apart. Molecules disintegrate. You cease to exist as a physical structure long before reaching the center. At the singularity, all known laws of physics break down. Our equations cannot describe what happens there. Space and time effectively end. This is not just the death of a person, it is the failure of physics itself. Does the universe forget you? For many years, scientists believed that anything falling into a black hole was erased from existence. But Stephen Hawking changed this view. He discovered that black holes slowly lose energy through a process now called Hawking radiation. Over immense timescales, black holes can evaporate. This raised a deep question. If black holes disappear, what happens to the information they consumed? Hawking proposed that information is not destroyed, but stored on the surface of the event horizon. This means the universe may never truly forget what falls in. Even if your body is destroyed, the information that made you could still exist in a scrambled form encoded on the black hole's boundary. Could black holes lead elsewhere? Some theoretical models suggest that black holes might connect to other regions of spacetime, possibly even other universes. These ideas remain speculative, but mathematics does not rule them out. In some interpretations, falling into a black hole could place you into a different universe with a different history. In one reality, you fall in. In another, the black hole never existed. From the outside, no one could ever know which version occurred. Once the event horizon is crossed, your fate becomes permanently hidden from the rest of the universe. The ultimate boundary of knowledge. Black holes are not cosmic monsters hunting the universe. They are natural outcomes of gravity, taken to its extreme. They shape galaxies and help structure the cosmos. Yet, they also mark the edge of what humans can understand. To fall into a black hole would not be dramatic in the way movies suggest. It would be silent, inevitable, and final. You would cross a boundary where time collapses, space twists, and reality itself no longer behaves normally. It would be the last journey any explorer could ever take. And no message would ever return. If you enjoy exploring the darkest mysteries of the universe, make sure to like and subscribe, because the next journey may be even more mind-bending than this one.